Welcome to this lesson on Introduction to Blockchain Technology, presented by Coding Bootcamps. In this lesson, we're going to discuss blockchain structure and types. We've already covered about the instructor, so please read more if you have any other interest. And in the previous lessons, we learned about the history of Bitcoin, the history of ledgers, some high-level architecture of blockchain. Now we're going to talk about the blockchain structure and the different types of blockchains. So blockchains track data. So just like a ledger tracks data, blockchains track data in the same way. A big tool of the blockchain are the hashes. So hashes are generally known as digests of data. And so with these hash algorithms, so there are hash algorithms, different ones will produce different outputs. Any data that is stored in fixed, when we talk about a digest of data, we can take any string, any alphanumeric string, and essentially convert it to an alphanumeric string of fixed length. So it will convert any data. It could be a sentence. It could be one letter. It could be several volumes of a book. They all would be hashed to the essentially an alphanumeric string of a fixed length. And there are different hash algorithms. So there's MD5, SHA-1, SHA-256. Hashes are very sensitive to changes. So if there's any change to the data that generated that hash, the hash is going to be different. So that sensitivity of change is probably the number one reason to use hashes if you want to know if any of your data has undergone any kind of changes. So let's take a look at some examples. So this string or this sentence here, what is blockchain, followed by the character here, the question mark character, hashes, we're using an MD5 hash algorithm. This is its 32 character hash right here. This number 1 million with the commas hashes to also 32 characters. We can see it here. A 0 hashes also to 32 characters. And this paragraph also hashes to 32 characters. So this is the MD5 hash. And again, different hash algorithms will have different outputs, but they will all follow those same rules that it will take an input and create an output of fixed length. Hashes are asymmetrical, so there are no inverse hashing functions. So in other words, we can't apply a formula to a hash and then return the input. There is no formula to reverse the output and get back what was input into the hash algorithm. So we cannot go back to this previous, we cannot take these hashes necessarily and get back what we put in. Sometimes you could see some applications do have that reversing function, but just consider that something more of a learning type of approach. Hashes are considered to be asymmetrical. So we could take a look here again how the hashes work as far as the blockchain. So the hashes are actually become part of a next block. So if we look here at block 40, block 40 has some data in it, some transactions. So we can see here the list of transactions added. And there is a proof of work hash that is generated from these transactions. And this proof of work then becomes part of the header for the next block. So we have block 40, we're going to block 41, and we see all these transactions, we see its output hash, and this output hash is in the header of the next block. So this is actually what we're talking about, the chain. This block now knows its successor because it's looking for its hash in the next block. So if anything here would change, these two hashes would no longer match. And the same thing here. There's a list of transactions again in this block. We have a new proof of work, and that proof of work then becomes the header in its successor block, which is 42. Another way to look at it here is, and this is more of an abbreviated way, we can see here Bob and George had some kind of Bitcoin transaction. Jay and Mark, the same thing. And a hash or block signature was created, which happens to be the header for the next block. Well, if somebody would go in and tamper with, so before in the previous, we saw George had, well, at least received 100 Bitcoin. If somebody went in and changed it so George would receive 500 Bitcoin, that would change the hash. The hashes would no longer match, and then this block then would be dropped, and a ledger from another node then would be brought in to overwrite this current ledger, or this current block. So let's talk a little bit about the types of blockchains. So we talked a lot about public blockchains. So with public blockchains like a Bitcoin or like an Ethereum, you have a fully distributed ledger. So you have the ledger on several computers, several users' computers throughout the world. Again, these computers are called nodes, distributed throughout the world, fully open, permissionless. Everybody has the exact same access. They can manage any type of asset or data. So this is not necessarily Bitcoin, but say this is Ethereum. Each node has full access to the full ledger, and they are immutable. So we saw the immutability. Anonymous, so we saw a lot about anonymity. Visible to all users, and the consensus is based on community, and smart contracts. So Bitcoin's a bit of an exception to certainly this point, any type of asset or data and smart contracts. Well, in order to work in a private business, not all of these attributes here would be welcomed in a private business. So if we wanted to set up a transaction system or a blockchain between businesses or within one business, we probably would not want all of those same attributes. We might not want fully open. We might not want permissionless. Each node having access to the full ledger. We don't want anonymity. Most likely we don't want that. We don't want the visibility to all users, and we don't need consensus of the community. We do want a distributed ledger, managing any type of asset or data, immutability, and smart contracts. So private blockchains have the distributed ledger, and data in this case, data can only be seen by those who need to see it. So there are permissions in a private blockchain. So examples of some private blockchains would be Corda, or Hyperledger Fabric, or even Hyperledger Sawtooth. They can manage any type of asset or data. Yes, that's what we want. The ledger is only available to those who need to see it. That's what we want. We still want the immutability. We want known users in this case, because for the enterprise, we want to know who is conducting. We want to know who's conducting the transactions. Visibility based on role. So again, depending on your role, what data you can see. Fewer nodes, and again, known users, and we do want smart contracts. And there is another blockchain type, sometimes called permissions. An example here of this one could be Ripple, and it's considered the permission blockchain. Again, distributed ledger is desirable, can manage any type of data or asset that's desirable, immutability, smart contracts, and the fully open, permissioned, each node has access to the full ledger, anonymity visible to all users. These would be undesirable in a permission blockchain. So again, permissioned blockchains are structured in a very, very similar way to private blockchains. So again, the known users, we still have the smart contracts, we still have the immutability, but again, permission to visibility, permission to access. And some popular public blockchains are Bitcoin, so the largest blockchain, and that's probably still true. Ethereum. So Ethereum calls itself more of an application platform or an operating network. So we know an operating system like a Windows or a Linux that you can run many applications on an operating system. Well, with Ethereum, calls itself an operating network. So you have a scaled up version of what we just talked about, the operating system. So you actually have different computer nodes on which to run your applications. And Ethereum was founded by a group of blockchain programmers. They were actually Bitcoin programmers. And if you want more information, you can go out to the Ethereum website. And some private blockchains: Hyperledger Sawtooth, Hyperledger Fabric. It is hosted by the Linux Foundation. You can go out and look at the hyperledger.org projects. Some of the contributors are IBM, Accenture, Airbus, American Express, JP Morgan, but there are many others. IBM does tend to be a large contributor and a very vocal contributor, but it is not an IBM product. It is open source and hosted by the Linux Foundation. Multi-chain is a popular, it's based actually on Bitcoin. I guess you could say it's a second generation version of Bitcoin that you can install on your own, and you can get more information at multichain.com. So either Corda can either be a private blockchain or it can be a permission blockchain. It's Corda. The vendor is R3, and you can go out to Corda.net and get more information. And Ripple as well, permission blockchain. And if you take a look here, you can see this in this matrix. We can actually see get some information about Ethereum. What's the industry focus? Who governs it? Obviously, you can see is it permissionless or permissioned? Items such as that. Kind of a useful matrix here. A little bit about, so if you want to go out and try some hashing, you can go out and try it. Here is one website that hosts a hashing application or app. And what you would do is you just simply go out here, and there are many of these. You can just search. This is just one example. You can go in, you can input a string, click the hash, and you can see the output of the hash. So you can get an idea about any small change, and you can see how the hash changes. So any small, well, obviously with just a single digit entry here, anytime you change it, that obviously would be a big change. But if you can put in several characters here, make a small change in that, you would see how much the hash changes. So take a look at that. So in this lesson, we discussed the hashing functions and the hashes and how they enable the blockchain and the hashes and the structure of the blockchain, introduction to different needs of public blockchains and the needs of the business enterprise, and introduction to some blockchain products like Ethereum, Hyperledger, Corda, and so on. Please complete the assessment. The answers are in the previous lesson we just completed. And again, for more resources, please check your learning materials. And if you're interested in more training, please also consult your learning materials. Next, we'll talk about blockchain operation and mining. And thank you.